I was going to take the weekend off, but so much tech news, I've just got to make a video. So first, let's start out with this headline. I think is a little bit dramatic. I'm getting this from WCCF Tech. We've got Navi 33 RDNA 3 GPUs allegedly featured within mid-range RX 7600 XT graphics card. That part seems reasonable to me. Around $400 US, that part seems reasonable to me. Faster than RX 6900 XT has yet to be seen, but what is all of this coming from? This seems to be mostly based on a Twitter conversation between 3dcenter.org and Kepler. Kepler has been known to leak GPU information in the past, although from my memory, which could be wrong, a lot of Kepler's leaks seem to be coming from if like a driver is updated, getting stuff from that or things like that. So in other words, I'm not sure how much insider source Kepler seems to have. I could be wrong on that though. It's hard to keep track of all of these various leakers and everything. But in this conversation, we're basically seeing some discussion of the memory configuration and amount about this Navi 33 GPU. With Kepler saying that it's 128-bit 8GB, which should be enough for 1080p or 1440p without ray tracing. Looks like 3D Center saying that, looks like no change to that memory interface, and it'll be a funny fight with AD104 RTX 4070 with 10GB versus Navi 33 with 8GB. But then Kepler's clarifying Navi 33 would be used in the 7600 XT, not the 7700 XT. So basically saying, well, that's not really your 4070 competitor. And then, so the conversation continues with 3D Center. Indeed, 4070 will likely compete with Navi 32, cut down, and Navi 33 likely to compete versus AD106. If you're lost on all of these N32s, AD106s, N33s, I'll clarify all of that in just a second. But anyway, my intention was to point out the mediocre amount of memory the RTX 4070 and Navi 33, despite their mid-range status, these solutions are not expected to be low-priced. And Kepler says, we will see the 7600 XT at $400 or less and 4070 at $500 or less. It's fine. Now, here, this could just be Kepler's opinion rather than claiming any kind of insider sources. And honestly, I think it's too early. I don't think AMD nor NVIDIA have probably finalized their pricing decisions on these cards at this point anyway, because as we get closer to launch, the GPU market and demand could change, and so their pricings could change. So I wouldn't read way too much into this. Now, if you're lost in all of these, like I said, N32s and AD106s and all of that, that's just the code names, the model numbers for the GPU dies that will be used to produce the actual GPU models. So like a Navi 31 is going to be the best RDNA 3 Radeon 7000 series graphics card. The Navi 32 would be a cut down one. Navi 33 would be cut down from there. Now, within each of those, each one can get cut down more. So, for example, you might have your 7900 XT and your 7800 XT based on your Navi 31 die. Whereas it's looking like here, maybe your Navi 32 would be like a 7700 XT, and then maybe your Navi 33 is like Kepler saying here, your 7600 XT. And the same kind of thing is going on with these ADs, with the 106 being cut down pretty far compared to like your AD, 102, which I think is our top end from NVIDIA. So it's the same kind of thing going on there. Now, I'm really interested to see what happens with these upcoming AMD GPUs, especially their launch dates. And NVIDIA, all the rumors are pointing to the RTX 4090 being what they launch with first. Could we see something a little bit more mid-range and affordable come from AMD, around that time frame? Is AMD also going to launch with their, Halo product first? It'll be interesting to see what happens here. But let's move on to some other topics because we've got a lot of them. In this video from Extreme Player on Bilibili, in a language I do not speak, so I'm going to reference an article based on that information. They have a Intel Core i9-13900K qualification sample. Now this should perform pretty close to the final chip. A qualification sample is usually closer to the final product than an engineering sample. So this is good information about the performance of the 13900K, but it's not a actually launched product with all of the finalized, motherboard and BIOS and whatever. But this is certainly a very good idea of what the 13900K could give us. And we've already seen them give us some productivity benchmarks. Now we're getting gaming benchmarks. So let's flip through a few of these and then get some thoughts, because some of these are pretty interesting. Some of them are pretty underwhelming. You can see here Far Cry 6, for example, which tends to be very single thread limited, isn't going to take advantage of the extra efficiency cores that the 13900K has compared to the 12900KF, which is the part that we're up against here. Both of them have 8 performance cores, whereas the 13900K is going to have an extra 8 efficiency cores, which helps a lot in multi-threaded productivity workloads. But in gaming, that's probably not going to be that big of a deal, although the clock speed difference will probably be our biggest help in gaming. We're seeing the 13900K going up to 5.5 gigahertz, with the 12900KF only at 4.9 gigahertz, and both of these were benchmarked on a RTX 3090 Ti. So we're seeing at most resolutions here, Far Cry 6 is not performing noticeably better. Like, it is better, but you wouldn't really notice it on the 13900K. Now, as we get into some other games, like Horizon Zero Dawn, once again, we are seeing extremely negligible performance gains, although in the 1080p minimums, it's at least a little bit more noticeable here, jumping up from 82 to 91. So it does seem to be at the 1080p minimums where we're seeing the largest gains here. And that's especially noticeable here in Red Dead Redemption 2, where we see the 1080p minimum jumping from 40.568 to 72.853. So that's a huge jump in the minimum FPS here at 1080p. Although, I'm wondering how often that shows up in the benchmark, because I'll tell you guys, when I run the Red Dead Redemption 2 benchmark, assuming that they're using the actual built-in benchmark here, a lot of times you'll get a minimum FPS result reported that is significantly lower than anything you really notice as you're running through the full 5 minutes of the benchmark, or however long it is. It's a pretty long benchmark. So this one seems a bit like an outlier. I guess that's what I'm saying, although it's still good to see that large gain. In Forza Horizon 5, we're once again seeing in the minimum frame rate department the largest gains here. With significant jumps at 4K, 1440p, and 1080p in the minimums, whereas the average and maximum frame rates don't see that much of a gain. It looks like at 1440p max, we're seeing the biggest gain, which is odd to me why we wouldn't see a larger gain at 1080p max than we would at 1440p, where you're more likely to be GPU constrained on the higher resolution. So that result, again, seems a little bit strange to me. Now, with Monster Hunter Rise, I just realized I'm a little bit in the way there. Monster Hunter Rise, we're seeing, again, not anything too crazy here other than 1080p max FPS and 1080p average. So at 1080p, we are getting some noticeable gains here. This is certainly gains here, and these ones are more noticeable than in some of the other games here. Final Fantasy XIV Endwalker, again, noticing some decent gains here. And PUBG Battlegrounds, again, some noticeable results here, especially look at here at the 1080p max FPS, 1080p min FPS, some very noticeable jumps here. So it seems like certain games are benefiting from this. CSGO does not seem to be one that's getting much from this at all. If you want to look at this overall, showing all of these, including some 3D mark, maybe I should just kind of disappear out of the way. Then, I mean, this is a lot to dig into here. But you're seeing the 3D Mark, Horizon Zero Dawn, Red Dead Redemption 2, Far Cry 6, Forza Horizon 5, Monster Hunter Rise, PUBG, Final Fantasy XIV Endwalker, and CSGO all stacked up here. And you can see that the Red Dead Redemption 2 minimums do seem to kind of be a bit of an outlier here. But most of the minimum gains do seem to be where we're seeing the largest results, whereas in a lot of other games, things seem a little bit more flat, but it's certainly some gains. Now, what is this going to be on average? Well, we did have some results here in the WCCF Tech article I'm getting this information from. They've kind of averaged out these results, seeing at 1080p, the average performance has jumped up 4.22%. Whereas the at 1440p, 6.97%, which seems weird to me because usually you'd be more CPU bound at 1440p. So, I mean, that's a couple percent off. Maybe this is some kind of a margin of error difference, but again, that seems a bit strange in the testing results here. And at 4K, we're seeing about a 3.3% gain. And so the overall result is a 4.83% average here. But you see in the minimum FPS margins, we're seeing 28%, 22%, 13%, and averaging out to over 20% minimum frame rate improvement overall, which is quite impressive if that ended up being the case across a large sample of games. Whereas the maximum FPS, again, is much smaller gains here as well. So it looks like Harukaze on Twitter had compiled a graph out of that data for another way of looking at that comparison. Now, the bad news on all of this seems to be the power consumption, because we did get a power consumption graph while gaming, and you can see here that despite in some games delivering only small performance improvements, the power consumption seems to be significantly larger in most situations, although in some of them, it's still actually fairly close. So it's not in every situation. It looks like the averages here are at 1080p, it's drawing 19.1% more power. So basically about 20% more power at 1080p and 1440p. I'm assuming this is a typo here, and this is supposed to be at 4K, where they're seeing 26.2% higher power consumption. So overall, the power draw has jumped up significantly, while the average performance gains seem fairly low, although the minimum FPS gains are more impressive and might be something that you'd actually feel more as removing some little stuttery dips in your actual gaming performance. Now, let's move on to Intel GPUs. Intel has been on a marketing spree, getting their Arc series graphics cards out there to US media outlets. And we've seen this video on Intel's own website here from their marketing. And the most interesting thing coming out of this video was actual performance versus the RTX 3060 coming from their A750 GPU. Now, the A750 is not their top-of-the-line GPU. That's the A770. So this A750 is significantly better than the A380 we've seen. So Intel's using, similar to their CPUs, a naming scheme where there's the A is like their generation. So this is their first generation, the A series. And then their performance tiers are A3, A5, and A7, with those broken down in between. So the A750 is a bit worse than an A770, which is their top end. And we're seeing against the RTX 3060, in F1 2021, we're seeing a 17% win over the RTX 3060. Cyberpunk 2070, 15% win. Control has 14% win. Borderlands 3 has a 13% win. Fortnite has a less impressive 6% win. But guys, here's the big deal. According to Intel's own marketing team, in this video, they're being very honest about the fact that this is a small subset of games that work very well with Intel Arc Alchemist architecture. They are not asserting that all games will show these results. So they're being very clear that this is what Intel Arc A series cards are capable of with the right software and engineering enablement. In other words, as we've seen, for example, with Gamers Nexus testing the A380, there are games like F1 2021 where the Intel GPU performs very well against its AMD and NVIDIA competition. But in a large number of games, especially games using older APIs like DX11 or DX9, it's simply not the case, and they completely underperform. And with interviews with Intel's engineers on Gamers Nexus videos, they've been very honest that the driver is a work in progress. They've targeted more modern games, newer APIs, and games that are showing up on top games played on Steam, things like that. Those are the games that they're targeting their driver development for initially. And so a lot of older or less well-known games are going to perform significantly worse than this, and that's the main thing that you're going to need to keep your eye out for if you're actually interested in these Intel GPUs. This is a best-case scenario, and maybe years down the road, after that driver has had a lot of time to develop, the 750 will perform more like this more consistently across a wider range of games. But these are your absolute best-case scenario, and most games aren't going to be performing this well. Now, speaking of the higher-end GPUs from Intel, we do have the A770 shown off on the WAN show with Linus Tech Tips, but we didn't get performance numbers out of that one, but we did at least, see that it exists. And then this is really interesting here. Well, actually, I should probably mention this. If anybody's been wondering, is there an A780, when we're talking about what is the top-end chip here, there had been leaks and rumors of an A780 being better than an A770. This appears to be completely false. Intel debunking that there never had been planned an A780. There's just the A770 at the top. So this is the rumored lineup with the A780 and A350 kind of crossed out as these probably don't really exist. The A770 is our top-end chip, followed by the A750, which we just saw can be a little bit better than an RTX 3060 in a best-case scenario. And the A380 we've already seen reviewed up against competition. Now, what competition? This is from WCCF Tech, and they apparently have a chart shared with, I think, Taiwanese partners for Intel, which should be pretty much accurate going into release this far along, of Intel's positioning against the their AMD and NVIDIA competition, including pricing tiers. So remember, we just saw the performance charts for the A750, and this is up against the RTX 3060. Notice that in this chart, they've actually got it slightly below the RTX 3060, confirming the fact that those 17% wins and things like that are outliers, and overall its performance is likely going to be worse than an RTX 3060. They have the RX 6600 up here as well, although really that should be positioned a little bit lower, or they should put an XT on that. So actually, given that that's 132 watt, I wonder if they actually mean the 6600 XT here, because that's the one that would line up better with an RTX 3060 for me. Anyway. Now we have the A770 positioned here, which is a little bit worse than a 3060 Ti. And again, they're putting this in the $300 to $400 pricing bracket, and it looks like they have nothing to compete with the 3070 and above. Their top of the line here should be a bit worse on average than a 3060 Ti. Their A580 coming in here along the lines of an RTX 3050. And then we've already seen the A380 reviewed, and in those reviews, it did come out worse than a 6400 and a little bit worse than a 1650. So this marketing slide does seem to be pretty accurate when we have GPUs like the A380 on here that we've actually seen reviewed. Now, this is interesting. The A310 is actually positioned here in a less than $100 pricing bracket, although at that top end of that. So I wonder if that indicates a $100-ish price point for an A310, although don't expect to get too much performance out of that considering how weak the A380 already is. And it looks like they're showing this as worse than a 1050/Ti. So now there's a large difference between a 1050 and a 1050 Ti, so I'm curious what exactly that means. And it looks like we're seeing that that's a 4GB graphics card. And we're seeing here on the A750, A770, some other interesting information here, like the power draw. Notice the power draw here places the 225-watt A770 as a worse performer than the 180-watt and 200-watt GPUs from NVIDIA and AMD. Same thing here, A750 at 225 watts. Again, getting beat by 170-watt and 132-watt chips from AMD and Intel. Also interesting to note, the A770 seems to have both a 16GB and 8GB configuration listed on this slide. So again, this information could be subject to change. That is even listed here on it. But this does look fairly up to date and somewhat in line with what we've been seeing on actual reviews that have come out here. Now, I think this is just another article on that same topic. So just a few last things before we go. It looks like MSI is adding screwless M.2 SSD installation to their AMD X670 and B650 motherboards, so that's kind of neat. We're seeing Lian Li launching the Lancool III, which is a successor to their very popular Lancool II PC case, with improvements. So these still look really nice. It looks like the main improvements are 4 pre-installed 144mm PWM fans, 51% porosity front panel, supporting 3x360mm radiators at top, front, and bottom. New look, all of that, advanced cable management. The MSRP on these will be around $150. And then we're seeing AyaNeo showing off their tiny little Air console, which has an OLED screen and an AMD Barcello, or Barcello? Would that be that? I don't know. Anyway, a CPU. Sorry, not CPU, APU here. And they're showing it off versus a Steam Deck and a Switch, that it's actually smaller than both of them. It's even smaller than a Nintendo Switch. So, you know, really interesting depending on the specs here. So this looks like it's coming with a 7nm APU with Vega graphics with 8 compute units clocked at 2000 megahertz. So that is actually pretty interesting specs and design. I've been having a lot of fun following these, little Steam Deck competitor style handhelds. I really kind of want to get one, but I don't know. We'll see. I'm not sure I'd actually end up using it very much. I hope all of you have an excellent day.